This video is going to show you how to solve an example problem using free body diagrams. A box is sliding at the bottom of an incline at 5 meters per second. If the coefficient of friction is 0.6, how far up the incline will the box travel? The box's mass is 8 kilograms and the box will slow to a rest. So first thing I'm going to do is I'm going to draw my incline. Just a dotted line or a faint line if I'm using a pencil, something to show my incline, and 24 degrees. Then I'm going to put my dot on there to represent the box. And I'll look at my forces. First off, I have a surface. That means I'm going to have a normal force that's perpendicular to the surface. I have the box has weight, so that means that gravity is going to pull it down. So that's going to be the weight of the box that I'm going to write as mg. And I have a frictional force because it told me the coefficient of friction. The box is sliding up the incline, so friction is going to oppose the motion and be parallel to the incline. That means that friction is going to go down the incline, opposing the motion of it sliding up the incline. And finally, it's going to be accelerating. But if I look at my forces, all my forces go down the incline. So even though the motion's going up, it's not accelerating up. In other words, it's not speeding up as it goes up the incline, it's slowing down. Because it slows down, that means my net acceleration is going to go down. And that makes sense, because if I look at my forces, I don't have anything going up the incline. So it's got to go down as the net acceleration. Now let me make a little room on the screen. And I'm going to take my MA net next, and I'll break it up into components. So what I'm going to do is I'm going to take mg, or I'll look at it, make sure all my forces are parallel and perpendicular to MA net. The normal force is perpendicular to MA net, so I'll leave it alone. Friction is parallel to MA net, so I will leave that alone. mg is not parallel or perpendicular to MA net. So what I need to do is find the components of mg that are parallel and perpendicular to MA net. So my first component I'll make perpendicular to MA net, going down. And that angle right there is going to be 24 degrees. Because that's 24 degrees and mg is the hypotenuse of my triangle, that adjacent side is going to be mg cosine 24. To finish my triangle, I've got the downward piece, and that's going to be mg sine 24. Now it's time to sum up the forces in the x and y direction. My x and y direction are going to be parallel and perpendicular to MA net. And that'll just make the math easier. The other thing I'm going to do is whatever direction MA net is going in, that's going to be the positive direction for all my forces. So I'll use plus and minus signs as direction indicators. If they go the same direction as MA net, I'll make them positive. Go the opposite direction as MA net, I'll make them negative. So in this case, I'll sum up the forces in the x direction, which will be down the incline. Because it's accelerating, it's not going to equal 0, it's going to be equal to MA net. And then I got to finish out the rest of the equation. So that's going to equal to friction plus mg sine 24. So if I look at the direction of the arrows of MA net, friction, and mg sine 24, they all go from right to left. So they all are going in what I'm calling a positive direction, or the same direction as MA net. Now at this point, I'm going to put in some numbers with units, and then I'll do a little bit of math just to make it look a little more pleasant. Alright, next summation. Sum of the forces in the y direction. In the y direction, it's perpendicular to MA net. By the way, if I didn't have MA net, I would just go parallel and perpendicular to the incline instead of MA net. But since I do have that MA net, the net force, I'll just go with that. So sum of the forces in the y direction. It's not accelerating in the y direction, so that's why I'm going to put a 0 right there. And that's going to be equal to all the forces going up minus all the forces going down. Because I don't have an MA net or a net force to compare to, I'll just have all the forces going up minus all the forces going down. Now I'm going to put in some numbers and do a little bit of math, and actually that'll give me the normal force. So normal force at this point is 7.62 newtons. So when I look at this, I want to find the acceleration in order to use kinematics to solve this problem, because I'm trying to find out how far up the incline it's going to go. I've got initial velocity, I know the final velocity, and I want to find the acceleration so I can find the distance it's going to take. But to do that, I've got to complete the top equation with a in it. So what I'm going to do is I'm going to use friction. Friction's great because it can tie in the two summations, sum of the forces in the x direction and y direction. So I'm going to take my frictional force, F is equal to mu times eta, and I'm going to replace friction in the top with the expression of mu times eta. So I'll rewrite that expression and replace the friction with mu times eta. And because I know what eta is, I know what mu is, I can just put those numbers in, and now it becomes really straightforward to find the acceleration. So when I solve the acceleration, I get 9.36 meters per second squared. But I'm not done. Because now I still have to answer the question of how far up the incline did it travel. I have the acceleration, and it's going to be negative because it's slowing down. I have the initial velocity of 5 meters per second. I have the final velocity of 0 because it says it comes to a rest, and I'm looking for x. So I need to use my kinematics equations to figure this out. So I'll use the v squared equals v naught squared plus 2ax. Plugging in my numbers, I get x to be 1.34 meters. So that's how far up the incline it slid.